Alright, ladies and gentlemen, let's get started with our Investing for Retirement Math Study Guide. Number 1 says you put $3,000 into a tax-deferred retirement account this year. Your marginal tax rate is 20%. How much did you save on this year's tax bill? So remember, some types of retirement accounts actually allow you to put that money away for retirement without taxing it. So that's what's happening to this $3,000 you put away for this year. So let's start with the $3,000 that we put away. And we know that if we didn't put the $3,000 into the retirement account, we would have had to pay tax on it. So our tax rate of 20% and then our $3,000 into our retirement account, we're going to multiply that by 20%. So let's go ahead and move that decimal place over 2, so 0.2, to find out just exactly how much we've saved by putting $3,000 away this year. So we have actually saved ourselves $600 by putting away $3,000 into a retirement fund. All right, ladies and gentlemen, let's take a look at number 2. You save $500 in a retirement account at age 25. It increases an average of 10% per year until you are 65. Which formula and result indicates how much money you will have in the account at age 65? Well, remember our compound interest formula. Let's remember that. And that was A is equal to P1 plus R, and then it was raised to T, which was time. So which one would best or most closely relate to our compound interest formula? So we've got A here would equal to 500 times 1 plus R, our rate, raised to our time. We're subtracting when we want to retire minus the age that we are now. So this one represents compound interest. Let's take a look at the second one. This would be A. This would be P. 1, our rate of R, but then it's multiplying it, not raising it to T. So clearly this is going to be our best choice for number 2, since it is showing us the correct compound interest. So $500 in an account at age 25 at 10% per year until we were 65. That means we would be holding that account for 40 years. After 40 years, that $500 would be $22,629.63. All right, let's move on to number 3. Your company has a plan that matches retirement contributions up to 3% of your salary. Your annual salary is 40%. You're paid bi-weekly, 26 times per year. How much should you contribute to the retirement account each pay period to take full advantage of the company match? So remember, some retirement accounts do this type of match program with their employees. They will put so much of their contributions and match those. So dollar for dollar, they will put in what you do to your retirement account. So let's figure out how we maximize this. If we are making $40,000 per year, it says they will match our retirement contributions up to 3%. So let's find 3% of 40,000. So 3%. So let's go ahead and move that decimal, make that 0.03. So that would be equal to a total of $1,200 per year that we want to contribute. So they'll contribute their $1,200. But we're not quite done yet because it wants us to say how much we should contribute each pay period. So we know it's going to be $1,200 for the year, but we get paid 26 times. So we're going to divide that $1,200 by 26 to figure out how much we should put away each paycheck so our employer will match the maximum. So $46.15 is what we should put into retirement each pay period, so we are able to get that matched dollar and cents from our employer to what we put in. Let's move on to number 4. You are now 25 years old and hope to save $1 million for retirement at age 60. You are very unsure about the outlook for investment returns. If you assume no earnings on your investment, how much will you have to save each year? So meaning you're not receiving any returns. You're trying to reach $1 million by the time you're 60 and you're 25 now. So let's figure out how long it is we have to save for our $1 million for retirement. So we want to retire at 60, and we are 25 years old now. So we're going to subtract those out, 60 minus 25. So we know we've got 35 years to reach our goal of $1 million before retirement. So our goal is, again, $1 million, and we've got 35 years to complete that goal. So what we're going to do is divide $1 million by 35 years to figure out how much each year we would have to save to reach our goal in 35 years. So each year, once we divide, we find out we would have to save $28,571.43 every year for 35 years to retire at 60 with $1 million. All right, let's take a look at the last one, number 5 here. It says you are considering a job that offers a pension of 70% of your highest yearly salary prior to retirement. You expect your highest yearly salary will be $50,000. What amount of savings, earning 10% per year, would you need in order to match the income from the pension? So first things first, let's figure out what our pension income would be. So once we reach retirement, we think that we're going to be making approximately $50,000, and it says our pension is actually going to pay 70% of our highest year. So we're going to multiply 50,000 by 70%. Let's move that decimal over 2 places, 0.70. So we know just based on pension alone, if we made $50,000 and our pension pays 70% of that, each year after retirement we'll receive $35,000 in pension income. What we want to determine is how much that would take us to save on our own, earning 10% a year back. So we know 35 is our goal to have each year. So what we are going to do is take that 35% and determine at 10%, so we'll move that decimal over to 0.10, we need to multiply that by the amount of total savings that we need to get that pension each year at 10%. So 35,000 is equal to 0.1 times the amount of total savings. So what we're going to do is we're actually going to divide both sides of the equation by 0.10 and figure out how much we would need to save. So when we divide 35,000 by 0.10 or 10%, we would have to save $350,000 in order to match the income from our pension.